Hello, it's Chandler Klebs again, and this video is mostly for me because I highly doubt that there will be very many computer programming nerds interested in this video, but I believe this will help me remember a few things about what I've been working on recently. So I'm going to record not just a few things that my unicorn project can do, but also I'm going to be doing some coding while I record the video, which I don't think I've ever done before. Okay, so first I have to get started by setting up my MSys thing. So first I always click this shortcut and it will load up its little thing. So it takes a while. Okay, and notice how it says hello unicorn, welcome back to MSys. Well, that's because I told it to do that. Okay, so I'm going to show you something. Here's the shortcut that goes to my home folder. So let's see now. Let's see the one. Oh yeah, bash profile. I think. Yeah, actually, this is very interesting. There's two profile things. There's this one. This is profile. Okay, this file is not read if .bash profile or bash login exists. Okay, so that's right. So bash profile is apparently the one that I edited on July 26, 2018. I'm going to open this file. Now all this stuff at the beginning here, that was already there. But basically, let's see what this says here. The copy in your home directory, bash profile, is yours. Please feel free to customize it to create a shell environment to your liking. Okay, so these lines here at the end, where the echo statement, hello unicorn, welcome back to MSys, because I put that echo command there, it will always say that to me, and I can change the message. Another thing I did here is I did path equals path and with the colon and then CTCC, and I'm going to show you why I did that, because this is going to help me tremendously. So see if I do path without the $, it just does that, but variables start with a $. Notice how I figured out how to add the folder to my path that contains the tiny C compiler. So I'm going to show you something. I can type which TCC and it shows me where it's at. I can do which GCC and it shows me there in like the Unix style. And if I just do CC, it also shows that. So see if I do TCC, then it shows the options of how you use the tiny C compiler. Oh, I'm going to enlarge this window. Okay, so that's what it does. But if I do GCC, then it will say fatal error, no input files. So I have both compilers set up. It's actually really cool. So I can use either of my two C compilers that I have installed on here. I like TCC because it makes really small executables, but I also like GCC just because, you know, I'm used to it. I don't know if it's really better than TCC. I can't say. But my program compiles and runs just fine with both. So now that I have my environment set up the way I like it, I'm going to go to my C folder, and this is where all my source code here is. So there's two things here. My mains.c file and my unicorn.h file. My two files I've been working on for a really long time. And the source code is getting quite huge. If you look at the file sizes, you see my unicorn.h is 11 kilobytes and the main.c is 2 kilobytes. So here's the thing. And the commands that will run either GCC or TCC are both here. So I'm going to show you what it currently does. Okay, I'm going to do the GCC command. I'm going to copy that, and then I'm going to paste that into this window. Oh, that's right, I'm not in the right folder. Okay, time to change directory to C unicorn. And if you don't know why it's called unicorn, that's just because I love unicorns. The program has nothing to do with unicorns. I wish it did, but I'm not that cool of a programmer to actually do something like that. Okay, so Now that that's worked, now I can do this command, and we'll see what it does. Okay, now what you see here, this is crazy. You see this is the Fibonacci sequence, where each number is the sum of the previous two numbers, the way it's set up, because 1 plus 1 is 2, and then 1 plus 2 is 3, 2 plus 3 is 5, etc. And you'll notice the numbers can get really large there, but trust me, you have no idea. I completed my Fibonacci function recently, and okay, I call it Big Fib. A shorter name for Big Fibonacci numbers or something like that. Okay, so here's what it does. It takes the argument length. Let me make sure this is still recording. Yeah, I think it is. Yeah, and it's recording my audio because my explanation is important for anybody who actually takes this video seriously, though I don't know of anybody who actually will. But this is a very incredible program. What it does is it takes one argument for length, and then it has 3 care pointers, which will become arrays. They get memory dynamically allocated with malloc. And the A-length function, I'll explain that later, and then there's X and I. X is used for indexing the arrays, and I is simply a temporary integer variable that's only used here for the processing of the carry variable. Basically, it's the carry variable, so if the result is over 10, it has to make sure that it continually takes it to the next digit. And so first it sets them all to 0, then sets the bottom element to 1. So that will represent the number 1, and A length is set to 1. This is important. And A length is simply, it keeps track of how many digits are currently used in the array. So it's the current length of the A array, whereas the length is the maximum length. However, I made sure originally it processed through all the elements of the array, but it wasn't necessary to do that because most of them are zeros, and there's no point in trying to add a bunch of zeros. So what it does here, first of all, okay, so while A length is not equal to the length, it does all this. Now first let me show you how it works. Okay, so Big Fib, I is set to 11, and so Big Fib is 16. So I'll show you something. If I set this number to 4 and then I recompile and run the program, it will go until the number is exactly 4 digits, basically. And if I set it to 8, it will do it until it's exactly 8 digits. So, as you might expect, I can go larger. I can tell it to do 64 decimal digits, and it will do it. And I can do thousands or even millions of digits long of the Fibonacci numbers. But considering how long it gets with just 64, let's just say nobody can ever actually look at it if we have millions of digits. Plus, it starts looking weird once it gets past wider than the screen. So I mean, and I don't know if anybody will care about my explanation how this program works, but here's a basic rundown. First of all, it does this thing where okay, so it uses the C array as a temporary place. Like it sets that digit of the X, the index, to be the sum of A and B. So C equals A plus B, but it's doing it digit by digit. It's very weird. So then what it does is it always adds the carry. The carry, it starts out as 0, so it does nothing the first time. But then it sets it to the carry variable to be that element divided by 10. So it gets, the extra digit. If it goes 10 or greater, it will be the carry. So it'll end up being 1. It's going to be either 1 or 0. Standard addition. You're doing addition. If the numbers is 10 or higher, you have to carry the 1. So that's what my program does. Okay, now, and then it mods, it gets the remainder, the modulus of that element divided by 10. So that means it deletes the extra 1 from the number because the carry will actually add to the next digit. And I've done this kind of thing before with my Powers of 2 program. So translating into this wasn't that hard, but I made some terrible mistakes, and I crashed my computer a few times because I was somehow writing to memory that didn't exist, and I got a segmentation fault. Oh man, weird stuff happens when you program in C. And so it's recommended to do Java if you're looking to do this more safely. But luckily, no damage is really done. In fact, it didn't like totally crash my computer, but it did cause a huge error, and it gave me like a stack trace dump or whatever. It was weird. Okay, so then, this code isn't actually that huge. So then what it does is it keeps track. The x goes from 0 to a length, the current length, but then what it does is if I is greater than 0, if the carry is still greater than 0, if it's 1, for example, in this case, then it will go to the current a length, or x, which equals a length at this point in the loop. It will always equal a length. So it sets that element, that digit, to be equal to the carry, and then it increases a length by 1. That means the program recognizes that it has an extra digit, basically. So basically that's how it works, is it recognizes that it will have an extra digit, so that it will print it. And I'll show you something, because now you saw how it just looked here, where it does this, and it knows my program is smart enough, because I coded it to be smart enough to know that it has to display an extra digit. But before I was that smart and coded that, I had a different method of how I did it. Okay, now first of all, moving on, this one here is very simple. What it does is it sets the B, all the B digits to equal all the A digits. So it's setting B equal to A, and then it sets A equal to C, which is the sum of the previous A and B. So this means that they get cycled through. It's just a filter that way. And there are probably other ways that it could have been done. I thought about even using pointers to like switch them around rather than actually changing the arrays. However, the only reason I would do that is for speed reasons, but it's very fast. It's fast enough for my purposes. Plus, this is a simpler way of doing it. And now this line, the most important line, without this line of code here, where we set x equal to a length, and then while x is greater than 0, first we decrement it so it doesn't print outside the bounds of the current array. And then it will print that element using the printf function. I could have used one of my other functions, but printf is, it's portable, obviously, for any C program. And then after the end of the loop, then it prints the new line. So I'm going to show you something. So if I tell it x to equal length instead of a length, if I remove that a there, and then I rerun the program, watch this. Aha! You see how it works? Now I changed it. Now it prints every single digit, which is nice. I like the look of this because it lines them up with their place values correctly, and it's not too hard to do. But then all I have to do is put back the A there. Okay, so I did that. I don't know why I was tapping that key. It's a weird nervous habit. I don't know. Okay, so then it goes back to doing that. So it only displays the minimal amount of digits required. And just for fun, I'm going to call this function with a length of 1000, and it's gonna freak you out. It goes so fast, and the numbers are too big to fit in a single line anymore. but it keeps going. It can even go to millions, but it would take a really long time to run the program. So I'm not going to show you that. Instead, I'm going to set this back to 64. And then my other programs, like my big factorials function, are similar. Like if I set I to 10, it will, and you do the if statement, it will call the big fact, which is the big factorials thing. So this is interesting. This is the factorials, where you multiply, starting at 1, keep multiplying the next number. So 1 times 2 times 3 times 4 times 5. A very simple sequence, but notice that it can go up to 64 digits the way I've called it. And just like the other one, it can go to millions of digits of the factorials. Now, believe it or not, the factorial function was actually written before the big Fibonacci function. And it's up here. And notice the code is much larger. I'm not going to even attempt to explain this whole code here because it's very weird. But it's very similar. It's very similar. It was just really hard to do. And pretty much the reason this one was harder to code than the Fibonacci one is because, first of all, it has to keep track of each of the 3 arrays. It has to keep track of their length separately. So more variables were required. Plus, I used a separate index variable for each because they were not guaranteed to be doing the same one. And the reason for this, okay, now let's see. So because it cycles through the B array, and then what it does for each of those digits, it goes through here, and it has the I being multiplied by those two instead of adding. And then it uses Cx is always equal to the sum of Ax and Bx. And this is because when you're doing multiplication, as you know, you have to align the place values so that, if you've done multiplication on paper, you'll know what I'm talking about. So that, because you're literally having to make sure they all line up with their place values for each digit, and it's a very time-consuming process. My program, I don't think I have time to explain this whole thing, but as you can see from the example, it works. It just works. It's very impressive. And so I can get factorial numbers as high as millions or even a billion digits if I allocate close to it, like a gig of RAM, So it's very impressive. But the thing is, okay, but this and the other ones work in the same way in that they allocate the memory at the beginning, and they free the memory and then set the pointer to null. Technically, setting the pointer to null wasn't necessary. I just did that for style reasons. Okay, now this program is called self-mul. It means self-multiplication. A heavily modified version of the multiplication system to constantly multiply the A array of decimal digits by itself. The B pointer is identical to the A pointer instead of being a separate area of memory. It just helps to have a B array and B length variables be consistent with the original factorials function, but almost everything else has changed. And what I meant by this comment is, first of all, technically it's only allocating 2 arrays. And I copied this program from the factorials one. And I just had to modify it because I already had the multiplication down. But here's the difference, is that it's still trying to add A and B. It's just the A and B are identical. So the pointers are identical. Therefore, I'm literally multiplying the same array by itself. And of course, because I'm just multiplying it by itself, well, basically, here's how it works. And then if this is just a printf statement, how about I run the function? I need to just run the self-mul function. I'll set this number to 12 so you can see the self-mul function in action. Okay. And then see what it does? It displays which power of 2 it is. I mean, I wrote this, sure it can multiply any numbers, but I simply made this to display powers of 2 that are to an exponent to a power that is a power of 2. You know what I mean? Like, so there's 2 to the 256th power right there. And it has no practical limit on the number of digits it can do except available memory, just like my other functions. But yeah, so basically it works in the exact same way as the factorials one, but of course it's printing the A array, but the difference is it simply sets A to C just like the other one, but it doesn't need to set B equal to A because I'm not switching around the numbers like that. So, and then it sets A length and B length to C length, technically. I mean, it's because the new length of the C array, which is the number that was just multiplied, it has to keep track, and just like the other functions, it keeps track and increases the maximum index, and it does it in a different way, but basically it always keeps track of how many digits need to be printed. So as you can see, those 3 that I just showed in this video are really cool. I'm very proud of these functions. Oh, I need to show you the negative powers of 2 function. Okay, let's set this number to 9. See, I just have this I variable that I switch which function it calls very easily. This is the negative powers of 2. I kid you not. I can do the negative exponents of 2, basically. So it starts at 1 and keeps dividing by 2. And it increases by exactly 1 digit each time, which is why that function was actually significantly easier to code than most of my others. And then, of course, people have seen my powers of 2 program before, but I'm going to show it again. I have several other functions, but I'm going to keep trying to keep this video short. Oh, the binary counter function. Okay, time to show the binary counter function. I almost forgot about that one. Can't forget the binary counting sequence. Yay! It counts in binary. It counted up to 16 digits, and they're all ones, and then it ends. All of my functions seem to be based off of that principle. They go up to a certain length. Now, let's see here. Now, this powers 2 function, I call it the ultimate powers of 2 function. Now, it's not as advanced as some of the other ones. Now, this one is weird because I'll show you this function in action. Now, this one powers to 64. Okay, so and I have set I to 8 to do that. Now, this function is a little bit different because what it does is it doesn't go up to a certain length of digits. That's not what this program does. Instead, this function, which was written before all the others, actually displays the exponent on the left, and then it displays that power of 2. So 2 to the 12th power is 4096. So it's simple, and I didn't bother to do the 2 and then the caret symbol or whatever you call that, the exponent symbol, because it's just obvious what this program does. Anyone who looks at this sees what it does. Now here's the thing, though. There is one little problem. Now this function does not dynamically allocate the memory. Instead, it uses the pre-existing unicorn array. So there's unicorn length and there's unicorn UX, which is the X index for the unicorn array. And all of these are global variables, and everything is defined right at the beginning, even before my putInt function, which I'm not going to show in this video. There's a constant here. This is the size of the array, and this size of this array is really cool because I can change the length of the array. It's a static array, meaning at compile time it's determined that this array is a certain length. And then there is technically I have the array is named horse, and then the caret pointer unicorn is is set equal to the horse array. And why did I do that? Because, well, unicorns are a horse. I mean, it's really funny that I did this, but I just did that because I wanted to have a pointer. But there's also a reason I could have just had the array named unicorn. However, I wanted to have that pointer be flexible. So, for example, if I wanted to change the size of the array, I could possibly do that. You know what I mean? Like, I could totally do that, so that, yeah, this is interesting. So I could change the size of the array, and there's some coding I may need to do to improve a few things here, possibly. And then this one, these variables are a global string, and they're only used by my putInt and getInt functions because they just need a temporary storage place. And I could have used the unicorn array itself, but I made a separate one, and it's named let's see, what's it called? Yeah, unicorn string. And Unis is the pointer to it. And then, of course, UX, UI, and UZ, those are the index variables used in my powers of 2 program. And most of my functions use UX, UI, and UZ, and use the global variables for all this stuff. But the big factorials, Fibonacci, and the self-multiplication functions that I showed at the beginning of this video, well, they use their own local variables, and functionally there is no difference. There's really no difference. I could have used my global variables, but you know, that's just the way I did it, and I can't really explain that. Plus, it doesn't matter because the code runs the same either way. And there is one, before I end this video, there is one tiny little problem. Now, because the array is static, because the size of the array is static for my powers of 2 program, which uses that array, means that if I were to set an exponent that is, say, let's say I did 2 to the, hey, I know. Let's say I did 2 to the millionth power. So let's say I set the exponent here to 1 million. The size of the array is going to quickly exceed, I mean, the number of digits required to display is going to exceed the length of the array. So when I run that, I'm going to get an error. I just can feel it coming, and I'm predicting there's going to be an error because it's going to sooner or later realize that the length of the array has been exceeded and start writing into memory areas that it's not supposed to. And I'm going to leave this running while I go to the bathroom real quick because I have to pee. Huh. Well, I'm surprised this program is still going. It's still going. Okay, yeah. Well, I don't know if I should let it run, but oh well, it's going to take a long time to reach 1 million. Okay, I'm going to just cancel the program, and then I'm going to set this back. But I already know for a fact that it would crash eventually. It takes a long time. I'm just surprised that it hadn't already crashed by the time I got back. But anyway, as you can see, I've been working on my programming very hard, and so I'm just really proud of my functions I've done. And I have so many functions, and I can do integer sequences up to the number of digits of available memory. In the future, I may make an upgraded powers of 2 function that dynamically allocates memory. In fact, I may just copy the whole code, but then change it so that it allocates the memory dynamically, like the others do. I could even make it so it doesn't even use the unicorn array. I've thought about doing that. I'm just not sure if I'll do it or not. But it works as is, so I could just do it that way. But anyway, I'll do what I do when I'm not recording a video. I actually wanted to record a video more of showing my programming stuff, showing what it can do first. And the process of coding can sometimes take hours, and I don't get enough time to do it. This has been the result of months of work. So just on and off whenever I have the time to work on it. So yeah, so that's the thing. Okay, so let's see. Yeah, see, because my mom never shuts up, and she doesn't understand the concentration if I'm reading or if I'm programming. And luckily she's gone right now, and I changed my work schedule. I changed my work schedule so that I'm working an hour later on my days, so that I'm working at 11 and starting at 11 instead of 10. This gives me extra time because my mom doesn't leave the house very often, but when she does, she's being picked up by the Rediscover van. So that's just the thing, is this means that I can get dressed at 10 and then walk to work. You know, I can get dressed at 10, and that means that since she's usually picked up around 9 or 9 something, that means that will give me almost an hour to work on my programming and to record videos. So that was actually a brilliant idea. That was part of the reason I requested the work schedule change, because I really need some alone time where I'm not interrupted. I really do, and it's just really hard because I want peace and quiet, and I don't get it around here. I live with my mom, so that's what's going on. So I'm finally able to record videos of my programming, and I want to record some more videos on my YouTube channel. I really do, because I have a lot of things to say and a lot of cool programming things to show people, and even games when I can get games to work. So I'm in a pretty good mood right now, which is unusual, but I'm always in a good mood when I'm left alone, and that just never happens. I wish it happened more often. So anyway, I'm happy right now, and in a few minutes I need to get dressed and start going to work. But if anybody is still watching the video at this point, well, thank you. Thank you for being a nerd and caring about my programming, because like nobody does unless they are a nerd. Like only my friend Ben Delheim, only he might even have a clue. He's like, he's taken computer science, he's done programming, but most people just aren't nerdy enough to understand my programming, and I really would like to be understood about this. And I would like to really teach other people programming, like the kind of stuff that I learned how to do. Although it's basic and I can't do graphics, I can't program video games, my management of arrays and doing math with integers is incredible. It's like my superpower. So I'm happy about that. Math gets me really excited. I tell you, I'm not normal. Like I told people, I'm not straight. I don't think about having sex with naked women, because straight men do. No, I'm thinking about integer sequences and video games and awesome foods that I like to eat. I mean, that's what's going on in my head all the time. So I don't know what's wrong with all the rest of the men in this world. So anyway, I'm going to shut up now because I don't want to run out of time.